Hello students, welcome back to the another session of our data structure journey. Today we are going to learn what is a circular queue. First we have to know what is the need of circular queue, what is a queue, what are the drawbacks of the linear queue, why we have to go for the circular queue. Then we will go to the implementation of the circular queue by help of the array. In implementation also we are doing in the C language. So let us understand what is a queue. For Q, I have already make a separate video. I put in the description section link. You can go and refer it. So Q is a data structure. Which type of data structure? It is a linear data structure that follow first in, first out. Means the element is inserted into the data. Q is going to be delete first. So this is the queue of 4 elements. So this is first element. Here the first element enter from this end and it's going to be out from this another. That is the DQ. NQ means it is the operation for the insert an element. DQ is the deletion operation is the called as the DQ. And there are two end. The end from where the element is inserted we call as the rear. Another end the element is going to be removed or delete we call as the front end. So what are the various operations performed on a queue? So first we have to know queue. Queue means it is a linear queue. NQ. NQ operation means insert an element at the rear end because in queue one end is used for insertion, another end is used for the deletion. And insertion end we call as the rear end, deletion end we call as the front end. DQ is the operation where we are delete an element from front end of the queue. It only returns the element and remove from the front end. Then there are two operations that we have to check whether our queue is full. Once the queue is full, we cannot able to insert the data. And that situation we call as the overflow. Then underflow means whenever the whenever the queue is empty, means there is no element present inside the queue, we call as it is a empty. And the situation or the condition we call as the underflow. So let us first understand what is the need of circular linked list, why we have to go for circular linked list. So let us take an example. This is a queue is present and queue, for example, this is the array where we are going to store the element. From this end, we are going to insert the value. From this end, we are going to delete the value. So this is the procedure. So initially what happened? Front equal to -1, rear equal to -1. So basic concept of queue, linear queue, I have already explained in one video. You can go to that. There all the things is given. So now front equal to 1, rear equal to 1 means both are point to this one, rear and front. Now we insert an element. We insert an element means now this value is incremented. So front becomes to 0, rear becomes to 0. So now this is 0, 1, 2, 3, 4. We store the value this one. Now then what happened? For example, we insert the value, then what happened? So now this is front, this is rear, both are point whenever we insert first element. Then we insert another element, 20. Now rear point to this one. Then we implement store another value. Then what happened? One by one, what happened? Now rear points to which value? This value. For example, we want to delete an element. So then what happened? This value is deleted. Now front points to which value? This value. So this one is deleted. Now front point to this one. Now for second condition, when we will tell that is a queue is overflow. For example, so we delete any value, then only the any space. Now here what happened? Rear is equal to front -1. What is the front value? This is 0, 1, 2, 3, 4. So on it will going to store the value. So similarly way we have to do the things. This is 3, this is 4. So this is 2. 2 means 2 is equivalent to 3 minus 1. So if this condition is true, then only we say that the stack is, sorry, the queue is full. So check for underflow. Underflow condition is that is which condition? If we If front equal to -1, then it is a underflow condition. Otherwise, space data is present inside the queue. Then NQ. NQ means how to insert the data value into the queue. So here also we have to check whether queue is full. If queue is full means there is no space, so insertion cannot possible. If queue is not full, then we have to check. If front equal to -1, then what happened? Make the front as well as the rear equal to 0. Reason is that right now we are going to insert a value and store the data into rear, because rear is the point where the insertion is going to be done and deletion is going to be done in from the front end. If rear equal to max size -1 means it will reach to the maximum size, but front is not equal to 0. Front is not equal to 0, it means space is there. Then what happened? We have to make the rear equal to 0 and store the value at the rear pointer. Otherwise means simple case we have to increase the value and store the element. For example, this is the case of for case 1. For case 1. So this is the 0, 1, 2, 3, 4, 5 elements. So what happened? Front equal to -1, rear equal to -1. This is the initialization. If front equal to -1 means there is no element is present. Right now we are going to insert the value. So then what happened? We have to make this one as a front, this one as a rear, because this end is the first elements we are going to store. This is the case. So we have to initialize both the pointer to the first element, 0 index, and store the first element. If rear equal to max size, let us take an example. This is the case. This is the case for this one. 0, 1, 2, 3, 4. So this is the indexing. Now here what happened? For example, we insert the value. Here we start the value 10, 20, 30, 40. Okay. So now what happened? After that, what happened? This value we make a deletion. This value also we make a deletion. Then what happened? If rear equal to maximum, this is the rear, right now rear. After that, if we want to insert any value, right now two spaces are there or not? If rear equal to max size -1, so what is the max size right now? 5, 5 -1. If it is true, then we have to check. Front is not equal to 0. Yes. When front equal to 0, if the data is present, if the data is not present, means this space is free. Then what happened? We have to make the rear to the this location. Now we have to make the rear equal to 0. So what happened? This is the case where we convert the linear queue to the circular queue. We point to the starting node. So and store the data. So this is the store the otherwise increase the if otherwise means right now this case. If you want there is a, this is not the end, rear is not maximum, then front is not equal to means data is already present. So simple, we have to increment the rear value and store the value whatever value. So this is the operation we have to perform whenever we go for the NQ. Next operation is the DQ operation. So whenever you go for DQ operation, we have to check if the queue is empty or not. If the queue is empty, we have to generate the underflow again and exit. If queue is not empty, then what happened? There are three cases. Access the data from it means which data you want to delete, you have to delete it. Then front is used to or to the next location of the data location of index where we can perform next deletion. If rear equal to front means single element. So here what happened? If this is a single element, then what happened? Rear equal to front. So if this is the front value, this is also rear means only one element is present because all the elements it is already deleted. Now all the elements to right now all the element is deleted, only the single element is present. That's why rear equal to front. Yes, both are right now 3. Then what happened? After deletion, we have to make the front as well as rear equal to -1. This is the condition for the empty queue. So that's why we have to make the front as a -1. If front equal to max minus means if the front equals this size, if we reach here, we are deleted an element, then means we reach the end of the queue. then make pointer to the performing, because it is a circular queue. After that, we have to move the pointer to here so that whatever data present inside this zero index, it can be deleted. Otherwise, what happens? Simple, we have to increment the pointer, because front pointer is one index to another. Once you delete, we have to move to the next location. This is the case of simple linear queue. Display also little bit complicated than the linear queue, because here we have to delete the element, not like a linear queue. So if rear is greater than the front, means front is used to, for example, this is the front, this is the rear, this is our 0, 1, 2, 3, 4, 5. Now if front is the element is going to, this is the 20. Now in this case, what happened? Two element is present. So here what happened? We have to print from 10 and 20. So we have to start from the front to the rear index. We have to just print 10 and 20. So it is very simple to print, because after zero index, this is the starting point. This is the 0 point. After that, what insertion is going on as well as the deletion is going on. And simple else means here 50 is present. After zero index 10 also is present. For example, 20 is present. Now otherwise, what happened? Print front to the maximum size. So here what happened? This is the front. So this is the rear end. After that, we can insert the value. So now what happened? Because here this is here is 0 means what? It already reached the maximum size. After that, insertion starting from this end. So this you can think the printing of two part. First one is the front to the maximum size, then from 0 to the last position of the insertion. So we have to print 10, 20, 50. How to print? We have to write down for I equal to front, I less than equal to max size minus 1, I plus plus. We have to print the value of I. For this part, we have to write down for I equal to 0 to I less than equal to, because rear is the position where the insertion is going on. So according to that, we have to print value. So this is the way we have to print the value. So next we are going to implement in the C language. Let us implement the algorithm. So this is the program. Circular queue. Circle queue operations. So first we have to include the header file. Only stdio is required because we are using printf, scanf, no other inbuilt function we are using. So for example, for queue, we need a array of, for example, 100 size. But each and every time user asks the end user to tell the maximum size of queue. So we define a variable that is max size. We store the size of queue entered by the user each time, and we make it the global so that each and every function can able to access. Then we have to make the front. Front we also initialize is the -1. Also it is global, so that enqueue, dequeue, display, all the function can able to access the front. Then rear also -1. This is the initialization of front as well as the rear. Then first function we have to complete is full. So it will return the true or false. For true it is 1. For false it is 0. So is full is the name of the function. For simplicity, I always make the function does not take any parameter, does not return value. So what is the condition? First condition, if front is equal to 0 and rear is equal to max size -1, because indexing from starting from 0. So this is both the condition, it should be double and both condition is true. Or or rear equal to front minus 1. If it is same value, then only we consider this is a overflow. So this both the conditions should be true. If this condition is true, then only we will make the then we have to return 1. Then it means that our Q is full, else return 0. So this is our each full function is completed. Now we have to go to the empty, is empty. So function name is the is empty. If the Q is empty, it returns the 1, otherwise it returns 0. So function return 1 or 0, that's why we have to write down integer return type is empty. So for empty initialization, we make the front equal to -1 and the deletion performed from the which end? That is the from the front end. So if front equal to -1 means no element is present. That's why we have to write down if front equal to -1, then returns which value? 0 value, 1 value. Return 1 means it is true. Else comes 0. So is empty, is full is completed. Now we have to go for NQ operation. So same concept. Function does not take any parameter, does not return any value. So simple for inserting means NQ. We at that time you have to check whether our Q is full or not. Full means there is no space. If there is no space, we cannot able to insert. So we have to check if each full returns true value. Then what happened? We have to write down printf Q is full. Overflow condition. Overflow. Then we have to exit, no need to proceed further else. Else means space is there, Q is not full. If Q is not full, then we have to ask the user to enter the value. Printf enter data into circular queue. So whatever we enter, it will store inside the, for example, n. Any variable we can store, for example, n. So we have to declare also integer n. Once it reads the value, then it will check which position and it has to be entered. Means it has to increase the font as well as then only store. But before that, it will check if front equal to -1 means our Q is empty. If Q is empty, then what happened? We have to make the front equal to 0, rear also equal to 0. We can write down in a one line, but for simplicity to understand the concept, I just make each and every point is the separate line. Then we have to store the item in a rear position because rear is the end where we are going to insert the data from that side. So we have to make the front as well as the rear equal to 1. These two lines we can make the front equal to rear equal to 0. So this is the case for Q is empty. If Q is empty, then this is the things we have to do. Then else if means what we have to do? Else if we have to check if rear equal to max size -1, it means the insertion rear is already reached in the end of the queue and we check whether is there any space or not. How to check the space is present? If front means after insertion, if the deletion is Done. Then what happened? Front is not equal to 0. Front is already increased by 1, 2, 3, 4, or 2 and max minus 1. So if front is not equal to 0, if front is not equal to 0 means certain items are already deleted. If certain items is already deleted means space is there, then what we have to do? If rear equal to max size and space is there, then what we have to make? We have to make the rear equal to 0. So this is the step where we make the linear queue to circular queue. So we convert the linear queue to the circular queue. Then we have to store the information, that is rear equal to 10. We store the value. So this is the case is with that. So next one means simple insertion, because this is the case if the queue is empty. Otherwise, we have to convert the linear queue to the circular. This is the step where we convert the linear queue to circular. Otherwise, what happens? Simple, we have increase the rear as well as the add the element. Simple steps. This is the procedure for the linear queue. Then rear equal to which value? We store the n value. So this is the value is over. Once it is over, so this is the case for the else part. Then what happened? We can print that printf new line insertion completed. We can write down this is so this is our NQ operation. So once the NQ operation is over, then we have to go for DQ. DQ means delete an element from a queue. Here we are going to perform the circular. So whenever you go for DQ, then what happened? We have to check whether data is present inside the queue or not. If the data is present, then only we can go for deletion. So if is empty is true means our queue is empty. Then what happened? Insertion deletion not possible. So we have to write down printf new line queue is empty underflow. Simple else. Now else means queue is not empty, data is present, we can delete the data. So first what happened? Deletion is the done from the front side. So first we have to print which data is going to print. So printf new line %d is deleted. So which value deleted? Value is deleted is queue front, because from front end we are going to delete. So we have to make the front. After that, we have to increment the front. So here certain things we have to take care. We cannot make the front arbitrarily to any location. So we have to check whether it is a last element. If it is a last element means or single element present inside the queue. After deletion, what happened? Queue is empty, so we have to check if front equal to rear. It means that what? If front equal to rear is means single. So single element is going to be deleted means after deletion what happened? Front and rear both wants to be minus 1. So front equal to minus 1, rear equal to minus 1. In one line also we can write down, but I make the things clear for each and every story. So that's it. Else if another condition we have to check, if front equal to maximum size, if front equal to max size, if front equal to max size minus 1 means the font already reached the end of the queue of a if you think as a linear, then what happened? It has to be point to the first element because it is a circular queue. So then what you have to make? You have to make the front equal to 0. else. Then what we have to make? If else means it is not maximum size, then what happened? We have to go simple increment the front plus plus. So this is the case if the queue has more than one element. This is the case if the queue have only single element. After deletion, what happened? Queue is empty. That's why we make the front equal to minus one, rear equal. Otherwise, means if the queue have more than one element, then we have to check whether after deleting the element, front is the maximum size minus one means it is the end of the queue size. Then what happened? We have to end of the index. Then you have to make the index points to 0 because it is a circular list. Otherwise, simple we have to increment this one. So this is our DQ, that is the deletion of element, then void display. Next function we have to write down display because we have to print the value. So in this program, I am not going to write down the pick or any of the simple. We just perform the circular queue. Pick means what? Front element we have to just print. So this is the things we are already covering the linear queue. You can go and add the condition. It is not that much big thing. So whenever you go for display, means we want to print what are the element present inside the circular queue. Same thing if the queue has no element means empty queue, nothing to be displayed. So for empty, what we have to do? We have to check if is empty. If is empty equal to true, then what happened? Printf queue is empty. Then we have to print queue is empty. Then we have to print queue is empty else. Else means you have some element. Then we have to check whether front is rear is greater than front. If rear is greater than front, it means that the element is inserted like a similar as a linear queue. So if it is linear queue, simple we have to print the value in from the front to rear value because front rear is greater than the front value. Anyhow, the front value is going to be deleted first. So this is the sequence the element are inserted. So we have to traverse the queue from front to rear. So we have to make I equal to front front, then I less than equal to rear I plus plus printf new line each value no need to each and every time you don't have to go for new percent d. After that one tab should be present in between two elements. What is the information? We have to print the qi. We have to print and we are not define what is a I. So integer I. Now if we want to print here, we just print the element of the queue. New line. So this is the way it will be looks like. It's a front decoder, then you have to print. Else. Else means front is rear is not greater than the front. Then what happened? We have to print from front to maximum size, then from 0 to rear. We have to print. So for that we have to write down for I equal to front I less than equal to max size minus 1 I plus plus. We have to print this value, same thing we have to print. So I just copy paste. After that, we have, so once we print from the front to max size, means from to max size, then we have to 0 to rear we have to print. So for I equal to with remaining elements 0 to I less than equal to rear I plus plus. So here's the same thing we have to print. So this is our display function is completed. Okay. You can for simplicity, but it is not required. We have to put a parenthesis. Reason is that it is already single line for loops are already. It is. But anyway, I make it as a. Otherwise, you got confused. So now display function is over. Now we are completed the each full function is empty enq dq then display also. So we are already completed the display function. Now we have to go to the main program. So this is integer main. So here also we have to enter the choice. I prefer to go by menu drive program. So printf line 1 is for enq, 2 is for dq, 3 for display. Scanf choice. So here once we go for choice, then what happen? We have to put it in switch case, that is the choice. Whatever choice we have to put into the case. Case one. So case one is for the NQ. Then we have to copy the function name so that no error. Immediately we get the. Then case 3 is the display. Then break. Then default. So once, so here we have to make the do while. At least it will execute once. Then while choice is not equal to choice is not equal to 4. Let us compile the program whether we are getting any compilation error only. What is the error? Error is that if front equal to double equal to we have to write down. Then okay, semicolon it's required. Each and every statement should be ended with the semicolon. Then if okay, here also. Mm, do while maybe something. Okay, this is for switch case. Okay. Then this is for do. Okay, do is completed. Okay, then compile and run. Okay. Okay, here what happened? The user has to enter the maximum size. No? Here we design max size means user has to enter the maximum size. Okay. So here we have to write down printf new line. Please enter the size of can percent d, that is which value, that is the max size. Please enter the size of Q. For example, I enter the size is 5. So maximum 5 element we can insert into the Q. So display we have to enter tab now. That's why immediately it will display. Enter the Q, then new line should be created. Okay. After display, the new line should be created. Okay. Compile and run. So how many elements? 5 elements. So in Q, enter the data 11. So let us check where is the error. Okay. So in Q, here, okay, sorry, we are not mentioned on person. So how it will read? Let us compile and run once again. 5 element and now insertion is completed. 1, 2, 34. For example, I want to display. Display is 3. Circular key implementation using array, data structure present inside the 1, 1. Okay, so first element is the 11. So if I want to delete DQ for DQ, 11 is deleted. Then 12 is deleted. Then 34 is deleted. Okay, so we are getting correct answer. For example, I enter one value that is 1, 1, then 2, 2, then 3, 3, then 4, 4. Then we have 4, 4, then 5, 5. Then now 5 element we are already insert right now. 5 element is present and it's showing the is the overflow. Now I go for DQ. DQ. So now one space we created, now we have to check whether it's a circular queue or not. If it's a circular queue, then only we can insert the value. Yes, it's asked us to enter the value. So I enter the 9. So insertion is completed, go for display. This is the advantage of circular queue. Here what happened? Just see. So 5 element is inserted, so queue is overflow. After that, we deleted one item. So once we deleted one item, means we created space, then we try to insert it. After that, it's insert a value into the queue. This is the advantage of circular queue. And let us see the another program we are done in previous. That is, let open the file. And this is the program we completed by help of the queue. This is the program. Now, for example, you execute here. So it asks the enter the size. Same thing, I enter the size. Now, first value, second value, third value, fourth value, fifth value. Now we go for display 4. is display. So it display the value. Now I go for deletion. 2. Okay. Data is deleted. Again, I want to go for insertion. This is a linear queue. This is the implementation of linear queue which we are already done in previous case. But here what happened? Here it's showing error. After deletion of an element, it cannot possible to just see. Here we delete the element, but what is the showing? Queue is overflow. Instead of operation is, even though space is there, in case of linear queue, it was not possible to do. But which is possible in case of, this is the case. Now just see here. This is the program, just circular queue. Here after deletion, we deleted 11 is deleted, then enter the data into the circular queue. Insertion is completed. After that, it can be possible, but which is not possible in case of our linear queue. Linear queue, once it's reached the end, after that is because deletion is done from this end. This end we cannot able to use because it's a linear queue. This is the circular queue. This is the difference between the linear queue and, so this is the basic difference between linear queue and the circular queue. Insertion and deletion. Insertion can be done from one end and another end for the deletion in case of linear, whereas the circular queue you can do the both the cases. Memory required is less compared to the linear queue because here the deletion space we can again you can use it, and memory utilization is inefficient in case of linear queue, whereas it is efficiently we are using. In case of linear queue, we are following the fast come fast out. It has no specific order because still it is there, order is there, but we can able to insert and delete in any location as per the front position, as per the rear position. So it can be possible. Thanks for watching the video. Hope you are able to understand the concept of circular queue as well as the implementation phase. I have already shown the comparison between the linear queue implementation we did in the previous video and with the circular queue implementation in this video. Hope you are able to understand the concept. Please subscribe the channel, like the channel as well as the share the channel more and more. If you have any issue with during the programming part or during any theoretical part, you can give me in your comments. I will definitely try to help you out. Thank you so much.